Dear participants of the conference, I would like to present our research running under the title Big Data Approach to Developing Adaptable Corpus Tools. First and foremost, I would like to underline that this research is in its beginning stage and does not reflect our long-term aim. This article tends to present the solution of such problems like the lack of customization in available corpus tools, ambiguity indicator, effectiveness in processing large amount of text data. At first, we represent our corpus as a mathematical model, and this mathematical model based on a number of sets. These sets are A. This is the set of one language which contains books. B. Sentences of each book contains chapters. C. And each chapter contains sentences. In every sentence we can find pairs which represent each term of the our sentence. We have to understand that pair is used because it's important to know not only the term but also its position in the text. So we represent it as a tuple of term and its position. Also, to make queries and find similarities between different terms and documents, we use term document matrix. This is the matrix C, and this matrix contains term frequencies and inverse document frequencies of each term through the whole corpus. And in our case, in the columns we have chapters, and terms are in the rows. Through the building our corpus, we used next approaches. We are doing data processing, which comprises of tokenization, lemmatization, stop words filtering, post tagging, and extraction of n-grams. And we used a latent semantic analysis, a well-known method which used in warp search engines, and this method allows us to build queries, and these queries we will do on terms, documents, and n-grams. The core of latent semantic analysis is singular value decomposition, which based on decomposition of large size matrix M to matrices U, S, and V. Matrix M has dimensions H by M, U is M by L, S is a diagonal square matrix, L by L, V is L by M, and parameter L can be changed, and this parameter allows us to reduce sizes of matrices, and also matrix S contains concepts which are represented by singular values, and these singular values are located in the main diagonal of this square matrix. They are the standard ordered, and the most important concepts have higher singular value. Corpus tool preparation has workflow, which is presented in the next slide. It contains extract, transform, and load (ATL). This ATL contains stage of extraction data from SQLite format. We use as a source text we use Bibles in SQLite format. We extract them into Postgre RDBMS, which is used by a Spark tool, which is a big data tool, well known, and Spark can work with the Postgres as data source. At this stage, we also doing some filtering of the text, and at the stage of the preprocessing, we are doing tokenization. We extract engrams. We are doing post tagging, doing lemmatization, and stop words filtering. Also is at this stage. The next, we calculate statistics. It's TF-IDFs, which I mentioned before. It's frequencies, dependencies, different dependencies, statistical characteristics of each term and engrams, and different correlations between them. Also, we calculate TF-IDFs, and we are doing latent semantic analysis. The data will be stored, results of these computations will be stored in Postgres SQL and in HDFS, or it also can be, as optional, it can be Amazon S3 storage. This data will be used for making queries and next analytics. Results can be represented as some analytics, and we also make queries, and we also can generate different reports and different summarization of our data which are in this corpus. General overview of our corpus can be shown in this slide. It contains a web UI and a data platform, HDP. This is Hortonworks data platform version 3.1. The core component of this tool is Apache Spark and HDFS. Tools and libraries which we used in this research. This is Java 8 programming language, Stanford Core NLP, language tool for Ukrainian and Russian languages, Apache Spark version 2.3.2, which is available in Hortonworks data platform, PostgreSQL version 9.6, and Spring Framework, as especially its Spring Data and Spring Boot to make web UI. We calculate quantitative and qualitative parameters. It's frequencies and TF-IDFs of each term, frequencies and TF-IDFs of each n-grams. This is singular value decomposition for making queries, and we calculate top concepts for each book, which reflect the most important terms and documents. Our input text data is described in this slide. These are, as example, 6 books, 6 Bibles. The characteristics of these books are described in this slide. We also can see how many terms and sentences we have in our corpus. These are results of tokenization. In this slide is shown results of LSI latent semantic analysis calculation. We are finding top 10 related terms to the term light, svetlo, and svet in Russian language. We see weights and we see terms. Also, in this slide we see a parameter k, which is used in singular value decomposition. This is value k and k100 and 1000, and we see that in some cases we have differences between the words, and sometimes we don't see any difference, or this difference is not so large. So we see that we can reduce size of our metrics and calculations 10 times and increase some performance. So, conclusions. Requirements for needed corpus tool has been formulated on the basis of different corpus tools available nowadays. It has been suggested using a number of related sets, terms, sentences, chapters, books as a mathematical model of the corpus. Corpora tool implementation was realized on the basis of big data approaches by means of using distributed data structures and algorithms. In corpus tool developed appropriate libraries and programming frameworks were justified and used. Adaptability of the corpus is provided by the ability to set custom parameters for every text document and by the capability to make quantitative and qualitative analysis. Suggested approaches and methods of corpus data platform development have been verified by implementation of the Ukrainian, Russian, and English languages support and based on the example of the Bible text analysis. Thank you for your attention.